Electrolysis, continue. Let's see some examples, some calculations on electrolysis. Let's check the one on the board. I got it. I got it from NECO 2022. Calculate the mass of silver deposited when a current of 4.6 ampere is passed through a solution of silver salt for 90 minutes, just as I have written it on the board. So if you watch very well, the important thing to note there is the equation for the reaction. Because reaction here will give you the number of electrons. Don't forget what we learned last time. That number of electrons discharged is equivalent to the Faraday. It's equivalent to the Faraday. So silver is the bone of contention here. And everyone here knows that silver has one electron, solid. This is the reaction at the cathode. Reaction or equation at the cathode. So if you watch very well, silver is depositing 1 mole of electron. 1 mole of electron, which is the same thing as 1 Faraday. If you followed the last video, is 1 Faraday. So this thing simply means that 1 mole of copper, 1 mole of silver deposited 1 Faraday of electricity. Deposited 1 Faraday of electricity. And don't forget that 1 mole of silver equals 108 gram. That is the relative atomic mass of silver. This is to say that 108 grams of silver deposited 96500 coulomb of electricity. All these things are derived from the question. 1 mole of silver, 1 mole of every element or every substance equals the relative atomic mass. Just as 1 mole of a compound equals the relative molecular mass. That is it in chemistry. So if you watch very well, since 108 gram of silver represented this, now you know the formula that we gave that Q equals IT. That's the general formula. The quantity of electricity passed equals current times what? Time. From the question, you see that a current of 4.6 ampere is passed through a solution of a silver salt for 90 minutes. Don't forget what I told you that everything here must be converted to seconds. So if you work this in very well, it becomes 4.6 times 90 minutes. If you want to convert it to seconds, you multiply by 60. Just watch it very carefully. The current is 4.6 ampere times the time is 90 minutes, but you must convert it to seconds. I multiply by 60. If you check it very well, you will know what it gives. If you press your calculator very well, you see that 90 times 60 will give you 5400. And when you multiply all, you will get 24,840 coulomb. Don't forget that the unit for coulomb, unit for quantity of electricity passed, that is Q, is coulomb. So if you watch, you can now say that, remember that you were asked to find the mass of silver deposited. You have calculated the coulomb. So this thing simply means, since you have gotten 108 gram of silver, which deposited this, so if you are looking for the mass now, you will now have 24840 times 108 gram divided by 96500 coulomb. Don't forget this one is coulomb also. Remember, 108 gram of silver deposited this. Do you get it? Now, S X will deposit 24840 coulomb. So what do you do when we multiply? So you have to multiply this by this and divide it by this. It's a simple proportion. Or let's just do it this way so that you get what I'm saying. Since 108 gram deposited 96500 coulomb. Now remember they asked us to find the mass. Now that X mass deposited 248 this. So what do now is you multiply. You cross multiply. So this thing simply means 108 gram times 24840 all divided by 96500 coulomb, which is the same thing that I have done up here. So if you place your calculator very well, you are going to get the mass of silver deposited. So calculator has helped us. If you watch very carefully, don't forget what we did here, simple proportion. Now the column here will cancel this column. This here will cancel this here. Now when you multiply the numerator, it gives you the, so the mass of silver deposited is simply 27.8 grams. 27.8 grams, which you can approximate to 28 grams. That is the mass of silver deposited. You can approximate it to 28 grams. That is the mass of silver deposited. We are going to look for other examples. Let's check example 2.